a sleek, modern, ADA-compliant ramp loses its utility the exact moment it terminates at an unyielding revolving door. Schools frequently fall into an administrative trap, reducing the vast concept of inclusive education to a checklist of superficial physical fixes, a braille sign here or a widened door there, while leaving the surrounding infrastructure untouched. This animated wireframe reveals the scale of the problem. An isolated red line of accessibility cannot overcome a rigid, exclusionary structure. True inclusion requires a multidimensional, rigorously engineered system. Achieving equity requires a shift from localized compliance towards systemic environmental design. This systemic approach is a strict legal mandate in India under the Rights of Persons with Disabilities Act, which requires educational institutions to provide inclusive environments without discrimination. International frameworks, like the Individuals with Disabilities Education Act in the United States, enforce parallel requirements for equitable access. Both frameworks operate on the legal default of the least restrictive environment. By law, students must be educated alongside their non-disabled peers, using supplementary aids and services, unless the nature of a disability makes that arrangement educationally impossible. We are going to deconstruct these mandates and build a fully compliant, inclusive school model from the ground up. These foundational laws explicitly mandate the complete removal of any artificially constructed barriers to guarantee equal access for everyone. To translate the legal framework into a practical environment, we start with the physical container. This render shows the exact dimensional requirements for accessible corridors. They require a width of 1,500 to 1,800 millimeters to allow frictionless, two-way wheelchair flow. At intersections, independent mobility requires a minimum 1,500 by 1,500 millimeter turning radius. Walls require dual-height handrails mounted between 760 and 900 millimeters. For safety and orientation, these rails extend at least 300 millimeters past the end of any hazard or ramp. Circulation continues into the classroom, where entryways must provide a minimum clear opening of 900 millimeters. Desks must be adjustable, providing a vertical knee clearance of 680 to 800 millimeters. This ensures wheelchair users sit alongside peers rather than on isolated edges. These precise millimeter specifications translate the abstract theory of inclusion into physical autonomy. This diagram illustrates the window paradox. Students with low vision require abundant natural daylight, but open windows on upper floors present fall risks for students with intellectual or mobility disabilities. The solution relies on precise measurements. The sill must be dropped to between 600 and 800 millimeters, allowing seated students to maintain a connection with the outside environment. Safety bars then secure the opening. The gaps between these horizontal or vertical grills are restricted to between 100 and 120 millimeters to prevent head entrapment. Similar engineering is required for hygiene infrastructure. Inaccessible or undignified toilet facilities are a documented cause of increased absenteeism among students with disabilities. Accessible washrooms require a clear floor space of 2,000 by 2,200 millimeters. Emergency alarm switches are installed at two specific heights, 900 millimeters for standing use and 300 millimeters for use in the event of a fall. Compliant facilities protect student dignity, which is a prerequisite for academic focus. Physical space provides little value if a student cannot independently orient themselves within it. Navigation requires layered sensory systems. Visual redundancy uses high-contrast pictograms and communication symbols to provide routing and rule information for students with hearing impairments or autism. Auditory redundancy utilizes distinct sound beacons and specific bell tones to signal class transitions for visually impaired learners. Finally, tactile redundancy mandates warning pavers exactly 300 millimeters before hazards and braille signage noted on the latch side of doors at a height of 1,400 to 1,600 millimeters. Stacking these multisensory layers removes environmental friction, granting students the ability to navigate the campus without adult intervention. The physical dimensions and sensory cues are the hardware of the school. We must now install the operational software, policy, and behavior. The central mechanism of this operating system is the Individualized Education Program, or IEP. This formal plan coordinates special education specialists and general classroom resources to meet a student's unique needs. Behavioral management is handled through positive behavioral interventions and supports. This framework addresses student behavior through proactive guidance to replace punitive measures that damage self-esteem. The school governs peer interaction through structured buddy systems, formal age-matched programs that pair non-disabled peers with students with disabilities for practical and social assistance. Buddies undergo explicit training on safely guiding visually impaired students, using basic sign language, and establishing boundaries. This structured peer support is designed to reduce isolation and prevent bullying. Engineered social protocols replace social isolation with systemic integration. In an inclusive school, a positive staff attitude is a measurable set of professional behaviors. Educational research shows that targeted exposure and training in special education improves inclusion outcomes significantly more effectively than assuming natural empathy. That training centers on formal disability-inclusive communication guidelines, which emphasize dignity and equality. The formal default is person-first language. Staff say student with a visual impairment rather than blind student, unless the individual specifies an identity-first preference. Staff avoid euphemisms like differently abled or special needs and eliminate terminology that frames disability as a tragedy or an affliction to be pitied. Professional guidelines also discourage inspiration porn, the practice of excessively praising ordinary achievements simply because the student has a disability. Precise, respectful language builds the attitudinal architecture of the school, setting the psychological tone for the entire institution. When physical accessibility locks into policy and language, the system functions as a single machine. This is the reality of universal design. Ramps and dual-height handrails provide stability for staff, while acoustic dampening and visual schedules improve focus for neurotypical students. The outcomes are measurable. Schools report significantly lower rates of disciplinary issues across the campus. Students with disabilities show higher attendance rates and improved academic achievement in well-supported general education settings. Non-disabled peers also report increased empathy and a greater awareness of human diversity through daily interactions within these shared environments. Systemic inclusion functions as a rigorously engineered standard of educational excellence, elevating every individual within the school community.